Besides the electromagnetic radiation from the sun emits corpuscular or particle radiation. This type of radiation is created by a stream of fast-moving subatomic particles such as protons, electrons, nuclei, and other ions, all moving in the same direction. The solar corpuscular radiation is the flow of emitted charged particles from the sun. These charged particles contribute to the Earth's surface. The constituents of the solar particles include protons, electrons, and other trace ions. These streams of charged particles are guided from the sun as solar wind towards the Earth by the Interplanetary Magnetic Field, or IMF. The sun is known to possess coronal holes, which are the dark areas in the solar corona as seen in the solar X-ray imaging of the sun. They are seen to be dark because they are the less dense regions that emit less X-rays. These regions are characterized by open magnetic field lines. Coronal holes produce solar wind of high speed, ranging from 500 to 800 kilometers per second. The north and south poles of the sun have large, persistent coronal holes, so high latitudes are filled with fast solar wind. The galaxies and the other celestial objects, including the interstellar matter, emit particles, also known as corpuscular radiation, as well as photons, which are light radiation. Solar wind and interplanetary magnetic field. The solar wind continuously flows outward from the sun and consists mainly of protons and electrons in a state known as a plasma. The solar magnetic field is embedded in the plasma and flows outward with the solar wind. The Interplanetary Magnetic Field, or IMF, is an extension of the sun's magnetic field carried out into space by the solar wind. The Interplanetary Magnetic Field, or IMF, plays a huge role in how the solar wind interacts with Earth's magnetosphere. In this segment, we will learn what the interplanetary magnetic field is, and how it affects auroral activity here on Earth. The IMF is not completely passive in the solar wind. Because it is attached to the sun and has a small but finite strength, the IMF tends to cause the solar wind to rotate with the sun out to some distance above the photosphere. In doing this, the IMF causes angular momentum of the sun to be transferred to the solar wind. Coronal mass ejections. Due to solar eruptions events, there could be mass ejections like coronal mass ejections, or CMEs. CMEs are huge bubbles of coronal plasma guided by strong magnetic field lines that are ejected from the sun. CMEs usually adapt to the structure of the twisted magnetic flux ropes created from the plasma eruption from the surface of the sun. For more content like this, please subscribe to our channel, like and share the videos with your friends, and click the notification bell for latest uploads.